Alright, lesson 12.2, we are going to discuss the construction of box and whisker plots. You have had experience with constructing graphs and tables and charts and things like that. A box and whisker plot is another way that we can display data. And a lot of being able to deal with box and whisker plots is going to come down to following steps. But before we get to that, box and whisker plots is a display model that uses a number line to show the distribution, which is the spread of a set of data by breaking the data into 4 parts that we call quartiles. Okay, and I'll show you that. As I was saying, it is going to take some steps to build a box and whisker plot. So here are the steps. So in theory, if we can go from step 1 through step 8 and just follow this set of steps, which I'm going to show you how to do this here in just a second, you should be able to construct a box and whisker plot. Now that being said, here is also an example where we have a set of data, and then we arrange that set of data, and then we find pieces of information. Again, the previous slide has those sets, and I'm going to do an example here in just a second. And then your box and whisker plot will look something like this. This is your box here, and you got your little whiskers, sort of like cat whiskers that stick out to the side. And those are above a number line. And this shows a spread of data, in this particular case, from it looks like about 17 upwards to about 29. And so we'll talk about how the spread looks and all that stuff here in just a second. But again, the previous slide is your set of directions that you need to follow. So, example 1, the following is the number of points scored by a player during 11 basketball games. We're going to use the data to make a box and whisker graph. Now step number 1 is, and if you look back at it, I'm not going to flip back to it now, is to arrange the data. I will be flipping back and forth as we go along here, but we need to arrange the data from smallest to largest usually. But I guess you could go largest to smallest, but usually since we work smallest to largest, that's the easiest. Okay, so 10. And we literally need to put these in order. I don't see 11s. I see 3 12s. 12, 12, 12. Oops. Okay. So I'm going to mark these off as I go along. I don't see any 13s. I see a 14. I see a 15. I don't see any 16s or 17s. I see 2 18s. It's a poorly written 18. 18, so my 18s are done. I see a 20 and a 25. So the first thing that we do need is we do need these in order, and there are 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now step number 2, I'll flip back here. Use the least and greatest values to draw a number line. So now I have a number line here set up, and I need to make sure that my number line goes from at least 4 to 25. Now, whatever scale you choose to use is up to you. Let me see because like if I go by ones, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Going by ones is not going to work in this case. So I'm probably going to go by 2s. 2s should do it. So 0, 2, 4. I'm not going to label every line just because that will get a little messy. 6, 8. So right now I'm labeling every other one, even though I am going by 2s, because this obviously here would be 14. So 16, 18, 20, 22, 24, 26, 28. You'll notice here so I now have I have my number line going from at least 4 up to at least 25, and now I can fit my data on my number line. Okay, so let me go back here again. So use the least and greatest values to draw a number line, which the least and greatest values are going to be 2 of the pieces of information that we put on the graph, okay, on the box and whisker plot. Then I'm going to find the median. All right, and as you recall, the median is the number that falls in the middle of a set that is arranged from largest to smallest or smallest to largest. There are 11 items here, which means the 6th one in from each end. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 14 is my median. Okay, which that number we'll come back to in just a second. Okay, so I'm just for now putting a box on it. All right, and then we have step 4 is to find the lower quartile, which is the median of the lower half. And 5 is to find the upper quartile, which is the median of the upper half. So I'm going to take this, and so now that I have this is my half. So my lower half here, I'm going to find the median of this lower half. Well, the number that currently fits in the middle is 12. So that is called my lower quartile. Okay. Of the upper half of values, you'll notice 18 is sitting in the middle here. That is my upper quartile. All right, fantastic. So we've just done step 4 and 5. Step 6, above the number line, plot a point for each value from steps 2 through 5. So we're going to plot the least value, the greatest value, the median, the lower and upper quartiles above our number line. So again, so now we can throw 4 into this. We can throw 25 into this. So at 4, above 4, I'm going to make a dot. At 12, I'm going to make a dot. At 14, which would be right here, I'll make another dot. 18 is right here, make another dot. And you'll notice you're sort of putting them in a line. Okay, and then 24, 26 would be here, 25 would be there. Okay, so I'm bringing those 5 pieces of information down to my number line. Draw a box from the lower to upper quartile. Draw a vertical line through the median, and then step 8 will be the whiskers. Okay, so from my lower quartile to my upper quartile, I'm going to draw a box. This is, so therefore there's my box, and I'm drawing a line through the median. Here is my box, and then I'm going to draw a line from the end of the boxes, my quartiles, out to my lower and upper extreme. Okay, the lower extreme being the smallest number, the upper extreme being the largest number. Okay, so this is the box, and this box represents the spread of data in my grouping, and it's broken up into quarters. We have our lower quartile, which would be our first quarter of information. We have our second quartile, or middle group, I guess, so to speak. This is the lower 25, or the middle 25% on the lower end, I should say. And then the next 25% would be in this half of the box. And then the upper quartile would have the top 25%. The following, and now we're going to compare some data. The following is the number of points scored per game by 2 basketball players. Use the data to make a box and whisker graph for each player. Now, to save a little time, you'll notice I have already put them in order. So I'm going to go through the steps again. Okay, so from 7 to 39, you'll notice I've already done my number line, but if it wasn't done for you, we'd have to put it in. All right. So I'm going to go to finding my median. So let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 games again. So 1, 2, 3, 4, 5, 6. So in this case, looks like 15 is my median. 1, 2, 3, 4, 5, 6. Yes, okay. The median of the lower half here would be 10. Okay, that's the number that fits in the middle. Remember, if you have 2 middle numbers, you'll find the middle of the middle. And in this particular case, we have 20 at the top. All right, and again, we're going to throw in, when we actually do our box and whisker plot, we will also include our smallest and largest. So okay, let's go ahead and place my dots. Now I'm going to line them up with this A here. So 7 is approximately right there, and it's halfway between 6 and 8, obviously. And then 10 looks like that's about right there. That would be my lower quartile box mark, which if you want to put that mark now, you can. Go ahead. 15 is going to be right about there, above 15, where 15 would be on my number line. 20 is right here. And again, that's going to be the top of my box, which at this point, if you want to, go ahead and you can complete your box if you'd like to, and I'll put my median mark in there. And then 39 is way over here, approximately right there. And then my line, my whiskers, would connect here. Okay, so that's for player A. Now I'm going to cheat a little bit for player B. I've already done player B's information. Okay, so here's the box, which 9 obviously would be this point. 26 would be this point. Okay, so I have these two pieces, these two players, and I can use this information to do some more, to answer some questions about what's happened. So before we get to that, we're going to talk about the interquartile range here real quick. The difference between the upper and lower quartiles in a box and whisker plot. So if I take the number, whatever this number is at the lower quartile, and I subtract it from the number of this upper quartile box, that is the interquartile range. Okay. So now we're going to answer a few questions. Which player had the greatest median score per game? So if I go back here, and I got to bring this back up, I have to bring it up every time. So first of all, which player had the greatest median score per game? Well, obviously in this case, the median score for player A was there, 15. And for player B was right here, that was 17. So to answer the question, player B, fill this in, player B had the greatest median score, okay, and that's the greatest average. So player B had the greatest average score. Which player has the greater interquartile range of the scores per game? So if I go back here, and again I have to bring this up again, it pops out every time. So interquartile range, again, is the difference between the greatest, or the upper quartile and lowest quartile. So for player A, the upper quartile was 20. The lower quartile is 10. So 20 minus 10, the interquartile range in this particular case, is 10. All right, so that is the difference between the upper and lower. For player B, we had 21 for the upper quartile. We had 13 for the lower quartile. So the difference in that particular case, 21 minus 13, is 8. Okay, so we had 8 for an interquartile range there. So 10 for A, 8 for B. So which player had the greater interquartile range of scores per game? That ended up in this case being player A. So what that tells me is most of his scores near the middle happen to be bigger than player B's. The scores toward the middle. Which player seems to have a more predictable score per game? Well, if we go back and we look at these again, these box and whisker plots are a comparison of where the numbers lie in relationship to one another. And you'll notice that player A ranges from 7 to 39. Okay, so his scores are spread over a much wider area. Player B's scores range from 9 to 26, and you'll notice the box is a little shorter, which means that you have a lot of compact data inside the box. And so if we're talking about predictability, player B is much more predictable. His scores are more essentially, they're more clustered together. Where player A, even though he had a really, really nice game at one point and had 39 points, that makes him a little more erratic. Okay, so if we're looking for predictability, the more that we can take numbers and condense them into a smaller area, the more predictable that individual or that situation is. So in this particular case, player B is my more predictable individual. Y-E-R, player B. All right, so time for you to construct some box and whisker plots. Again, obviously, as always, if you need help, come see me, and good luck.